Hey everyone, welcome back to another session in IBDP MAI HL course. And today we are going to talk about this SL 4.2 having presentation of data, discrete or continuous, frequency distribution table, histogram, what is the cumulative frequency or cumulative frequency curve, how to find the median, quartile, percentile range and interquartile range in the cumulative frequency graphs. Also, we will discuss how to plot the box and whiskers diagram. We also call it box and plot diagram for a given data and how to find the data with the box and plot diagram also. Okay, so let's start with the presentation of data, whether it is discrete or continuous. Okay, then I will tell you how to draw the frequency distribution table. Okay, so let us consider that the marks of 80 IB students are given here. These marks are out of 100, right? So what do you think? Is it a good idea to keep it in a discrete manner? Like there are 80 points, right? So it's not a good idea to write all these 80 numbers. We need another approach, okay? So in this case, we can make a table, okay? For that, what you can do is divide this data set in intervals. Take the minimum and maximum value. So you will find that here in this data, minimum value is 41, and if you see the maximum value is around 98. So take the range difference of these two. So now it's totally up to us, or they will give us in the question what interval we need to take. So in this case, you can make 5 or 6, okay, intervals. So we can make an interval from for those values which are lying between 40 to 50, then calculate those values which are lying between 50 to 60, then 60 to 70, and so on. Okay, now let's do it. So let's calculate those values which are lying between 40 to 50, and here is the frequency, corresponding frequency for that interval, right? So here, find those values and calculate, count them. Those are lying between 40 to 50. Okay. So in this way, you can mark all these values, right? And after marking all these values, you can write how many values are there between 40 to 50, not 50. Okay. So there are actually 15 such values. So in this way, we can fill the table, right? For 50 to 60, we can fill, there are 18 values and so on, like 18, 11, 12, and so on. In total, the data contains total 80 students. So this is frequency distribution table. Now, if you see this, reading this values, this set is much easier than reading this part, right? So this is your frequency distribution table. Now, let's find the relative frequency and cumulative frequency also. We are done with frequencies. Okay, so this is frequency distribution table. Now, next is relative frequency. For the relative frequency, you have to take the given frequency of that divided by total frequency, sum of all the frequencies, you can say. So 15 by 80, that value is relative frequency. If you multiply it with 100, you can get its percentage also. Okay, so in this way, you will get 18.7 as percentage if you multiply it with 100, and so on, like 18 divided by 80 times 100 gives us the second value, which comes out as 22.5, and so on. Okay, now next part is cumulative frequency. In order to get the cumulative frequency, you have to just add the frequencies up to that. Like here it is 15 only. Now in this one, we have to write the sum of all the frequencies before that. So what is that? 15 plus 18, right? So it starts with 15, then 33, obviously. Now for this part, you need to add up all these three. 15 plus 18 plus 18. That gives me 51, and we can fill the entire cumulative frequency column in this way. Okay. Now, relative cumulative frequency, in the same way we can fill this also. So this time what we will do, we will use the same thing, 15 divided by 80 times 100, 33 divided by 80 times 100, and so on. So in this way again we can fill this table, right? 41.2, 63.7, and so on. Okay. Now, this was same data but converted in frequency distribution table, and we calculated relative frequency, cumulative frequency, and relative cumulative frequency. Okay. Now let me tell you how to draw the histogram corresponding to this and how to draw the cumulative frequency polygon, right? So for histogram, let's start with, we need to mark the points, like here it is lying starting from what, 40, right? So make a kink. Let's start values from 40 to 50, then 60, then 70, then 80 and 90. Okay, we try to write our x values or the independent variable values along horizontal and dependent variables along y. So here I will write the frequencies along y and marks along x. Okay, so now we have the frequencies like 6, 12, 11, 18, 18 and 15. So we can mark those 3, 6, 9, 12, 15 and 18 like this. So from 40 to 50, just draw rectangular strips. So 40 to 50 it is 15. So go up to 15 height, and this rectangular strip shows the data that there are 15 students whose marks are between 40 to 50. Now for 50 to 60, 18 is the value. So another horizontal with the height 18 units. Similarly for 60 to 70, another rectangle with the height 18. Now for 70 to 80, it is 11. So draw a rectangle with height 11. And now for the 90, 80 to 90, it is 12. So just more than that. And 90 to 100, it is 6 only. So let's draw 6. Okay. So this is the histogram. Width are same here. In this case, the width are 10, 10, 10, 10, 10. Right? Okay. So in this way, you can draw the histogram. Now, next thing is how to draw the frequency polygon curve. So for that, cumulative frequencies are needs to be calculated. Take, these are x values, right? There is an interval. So for drawing the cumulative frequency curve, first we need to take the mid values of these. So those are the x points for us. Okay, so let's add a column here for mid values of x mid values. Okay, so x mid value here is 45, here it is 55, here it is 65, 75, 85 and 95. Okay, so take these x values and cumulative frequency values are y values. So you will get points. Just mark those points. If you take x as 45, so 45 comma 15 is one of the points. Similarly, take a next point which is 55 and 33. Next point is 65, 51. Next point is 75, 62. Next point will be 85, 74. And last point is 95, 80. So these are 6 points. Now mark these points on this cumulative frequency curve. So here we have cumulative frequencies along y and marks along x. Okay, now plot these. Okay, mark these points. So we will have 45 comma 15 as first point. So let's take it here. Okay, 45. Then next point will be 55 comma 33. So it can lie here. Next point is 65 comma 51. So you can mark those points and you will find a curve like this. Okay, so now join this, join these points free-handed. The graph you are getting here is your cumulative frequency polygon. You need to draw it like this. Okay, that is your cumulative frequency polygon. Okay, from the given histogram also we can find this one, because from the histogram we can construct that table always. We can always construct this frequency distribution table from the histogram, or from the table we can draw histogram. Okay, now let's talk about the median value. Here we know the data is this one, right? Cumulative frequency. So we can also make the quartiles. Do you remember that quartile? It divides our data in 4 parts. Okay, so values below 25, and then values, mid values, and then taking values lying between 50 to 75, and in this way you can divide your data in 4 parts also. So it is just an example, right? So we can get the quartiles also that we learned in the last session. In the same session we will discuss few more questions on that, then I will explain everything. So now let's talk about histograms again. Histogram for are drawn for the continuous data, but if you have discrete data, then you can also draw the column graph simply for those 10, 5, 6 values only. Okay, so discrete data here. Now quartiles divides our data set into 4 parts, as I said. Okay, quartiles, if this is your data arranged in an increasing or decreasing order, so here you can get you can divide your given data in 4 parts. Okay, like this. So first one is quartile 1, quartile 2 is median, upper quartile, quartile 3. Okay, 25% values are less than quartile 1, 25% values will be there. 25% of the total data lies in Q1 to Q2, 25% of the data lies between Q2 to Q3, and 25% of the data lies above Q3. Okay, it is just an estimation, it is not exactly 25%. Okay, it is an estimation. Okay, now here is the question. It says the following diagram shows the cumulative frequency graph. We have to find the median. What's median? Mid value. So mid value, how many values are there? If you observe this table, this graph, you can find the last one is here, total 160. This graph is corresponding to one data of this 160 students, or 160 observations in total. Okay, now median will be what? Mid value. So if total are 160 divided by 2, what is that? 80. So now at 80, draw a horizontal line. At 80, if I draw a horizontal line, it meets it here, and from that point draw a line, vertical line on the x. So that gives us marks corresponding to that frequency. Okay, so you have to use the scale, and it gives you value here around what? 41 to 42, you can say. Okay, 42. So the median is 42. Now for interquartile range, what do you need? You need Q3 minus Q1. It's called interquartile range. Now let's find Q1 and Q2 also. What is Q1? Lower quartile. So take the data, 160 values are there, 25% values. So 25% of 160 will be what? 40. So go to 40, do the same. Yes, 30 is the value. So that is your quartile 1, Q1, because it is at 25% of the data. This data is 25% of that. This is another 25, right? Now go to next 25, which is at 120, to get the Q3. So Q1 came out as 30. Now let's find Q3, which is at 75% of percentile, you can say. So here, corresponding to this, yes, you can see we have 60 value, right? So 60 is the corresponding value. So Q3 is 60. Okay. Now Q3 minus Q1, which is our interquartile range, comes out as 60 minus 30, means 30 is the value. Now the 90th percentile, for that find the 90% of 160. What is that? So 160, 90% of that divided by 100. So that value corresponding to that we can draw the it is 16 into times 9 which is 144. So go to 144th observation somewhere here. Okay. That's 150, sorry. 144 will be somewhere here. Corresponding to that, we have a point here, and corresponding to that point, we can draw a vertical line which is approximately 74, or you can say 75. That's okay. You take 74. Okay. So at this point, the 90th percentile is coming out as 74. So in this way, you can find quartiles, median, interquartile range, or the any percentile they gives you. Okay. Now, the next problem, 5 number summary, or we also call it box plot or box whiskers diagram. 5 points are there. It's very important. If the box plot is given to us, we can also find those 5 values, or if those 5 values are given to us, we can draw the box plot. Okay. So for the box plot, we need these 5 points. First one is the minimum value of the data. So minimum value of the data, then second is lower quartile, then median value, then upper quartile, and the maximum value of the data. If you have these 5 things, yes, you can always draw the box whiskers diagram. Let me show you how. You have to take the minimum value, start with that, then go up to quartile 1, then go up to quartile median value, then go up to quartile upper quartile. So it is minimum Q1, let's call it M or Q2, it is Q3, and there is maximum value of that. Now make a box for this, and Q3 minus Q1, this distance will give me interquartile range, right? This is your box whiskers diagram. Okay. Now here the data is given to us. As you can see, this data is discrete, but we need to convert it into that frequency distribution table, because it is very difficult to read this, right? First thing is we can do that, but here they don't want us to convert it in that. They just directly say find the 5 number summary. So from here we need to find we need to find the minimum value, quartiles, and maximum value. Okay, and then we can easily draw the box plot. So let's come to minimum value first. Okay, here from this data, if you read this whole thing, you will find minimum value is 38. Your quartile 1, you know how to find the quartile 1, right? 25% of the data will lie there. The median is 55. Q3 is the upper quartile, and maximum value is 68. You can make a frequency distribution table to find these values, or you can use your GDC, but again, entering 80 values in a GDC is not a good idea, right? So it is time taking, but yes, you can do that also. Okay, your GDC will give you all the information once you enter this data in that. Okay, now but here it will be better if you draw a frequency distribution table and do the same thing in your GDC. Now the next part is box plot. So as I said, draw the number line, mark those minimum value, mark the quartile 1, median, Q3, and maximum value. This is your upper fence for outliers, lower fence for outliers. All the values more than that are outliers. All the values less than that, 34.75, are outliers, right? And you know outlier range, right? We can easily calculate the outlier range that we learned in the first session also, like Q1 minus 1.5 times the interquartile range. That's the lower fence value. And for upper fence value, we have Q3 plus 1.5 times the interquartile range. That gives us the upper fence value. Okay. Now time for the box plot. As I said, take the minimum value, starts from here, go up to quartile 1 here, then second quartile and upper quartile and maximum value. Make a box for these quartiles. That's it. So if the graph is given, we can always find these 5 points. Or if these 5 points are given, we can always draw the box plot. Even your GDC, in your GDC also you can go to statistics and you can draw this box plot as well. That we will learn later while solving the questions using the box calculator. Okay, GDC. Now, here's the question. Palvinder breeds Labrador puppies at his farm. Over many years, he recorded the weight in grams of the puppies. The data is illustrated in the following box and whiskers diagram. Okay, write down the median weight. So, as you know, median is this value gives minimum value. Here lies the minimum. Here lies the quartile 1. Here lies the quartile 2 or the median value. Here lies the quartile 3 and that one is the maximum value. So yes, we can easily mark these points. We can calculate the minimum value from the here. It is 100, right? Similarly, for the quartile 1 or the lower quartile, the value is here, which is 190. For the second quartile, the value is 210. For the quartile 3, it is 240. And the maximum value of this data point is 290. Yes, you are right. 290 is the value. Okay, write down the median weight of the puppies. So what's the median? Answer is from the graph you can see median is 210. Write the upper quartile. So upper quartile is Q3, which is 240. 240 is the value. Interquartile range. You can find the Q3 minus Q1, right? So 240 minus 190 gives me 50 as the interquartile range. They may ask you semi-interquartile range also. Then you have to take the half of interquartile range. That is called semi-interquartile range. Okay. Now, few more questions. It says for the following frequency distribution, find the proportion of the data items above 20. So, what are the values? How many values are there which are more than 20? Right? So, what you can do here? Simply look at the table and go to that part where observations are more than 20. Here, so 18 plus 12, 30 is the answer, right? So for this table, you can see total 30 items are above 20. Next, from the histogram, find the data items above 25. Above 25. So here lies the 25, right? 25. So it is just an estimation. It is not an exact number. See, between 20 to 30, how many? 4 values are there. Between 20 to 30, 4 values are there. So let's divide it symmetrically and say between 25 to 30, there are only 2 numbers. Don't take 4. It is just an approximation. From 30 to 40, this data shows 7 values, right? Because that is the height of the rectangular strip between 30 to 40. Gives me 2 plus 7 as my answer. So 9 is the value. Next. So in this session, what we have learned so far, let me tell you, we started with interpreting frequency distribution table, how to draw the cumulative frequencies, right? And find the relative frequencies, relative cumulative frequencies, then interpreting the frequency histogram, then finding the interquartile range, median, quartile, percentile, right? Particular percentile or interquartile range. Next, how to draw the box whisker diagram and using that box whisker diagram to calculate the mean, median, and we can also compare the distribution, right? We can also compare the distribution using that box plot as well. So that's it for today. I hope you got all these points. So if you have any question, you can ask me in the comment box. Thank you for watching this. See you in the next part. Keep watching, keep learning.